Hello everyone. So system design is easy to talk about on a whiteboard. You draw a load balancer, put an application behind it, add a database, and then talk about security, scalability, and observability in the abstract. What actually I wanted to know was what do these decisions look like when I have to implement them end to end in a real AWS account with the real trade-offs I have to live with. So I built a product called the NexusRetail. So the retail and invoice reconciliation use case, which is really just the vehicle. I picked it because it forced real decisions across networking, computing, identity, multi-tenancy, security, AI document processing. More importantly, human in the loop automation, CI/CD, and observability. See, not one of those in isolation. All of them in a same system, depending on each other. So I'm not going to walk you through this as a list of AWS services, right? For every piece, I want to explain why it is there, what I considered instead, and what I want to give it, what I gave up to get this. So let's start the journey from the user and then follow the architecture through the system. So let's start with architecture. So as I just mentioned, it starts from user entry. So user entry, every user starts at Amazon route 53. So from here, the architecture separates into two paths, the static front-end path and the API path. I separated them because they have very different runtime characteristics. The front-end is static after it's built. The API is dynamic application compute. So I didn't want to force both into the same deployment and runtime model just for architectural simplicity. The static front end, if you see here, there are two front end entry points here, the application and the landing site, right? Both follow the same pattern. So Route 53, CloudFront, and S3 Origin. After the React build, what I have is static HTML, GSN, JSN, CSS. So I had three options: serve it from the API container, or run a second front end container, or it treat it as a static assets. I choose S3 with CloudFront. Running static content inside ECS would consume application compute and couple front-end deployment to back-end deployment without giving me anything back for it. So the trade-off here is like separate front-end and back-end deployment pipelines. I actually discovered that gap while building this. No, I had automated the back-end, but was still deploying the front-end manually. I'll come back to that in the CI/CD section. Next, if you see the API entry point, so the DNS resolves the API endpoint to the load balancer. WAF is associated with that load balancer ALB. So requests are inspected before they reach the application. So conceptually, Route 53 to WAF protected ALB to ECS Fargate. So I didn't want in my application container to be the first line of defense against internet traffic. So WAF handles managed core rules, SQL injection protection, known bad inputs, and rate limiting. I didn't want to just say like WAF is, if WAF is configured, therefore secure. I wanted to verify the rules actually do something. So I'll show that live in the AWS walkthrough right after the architecture walkthrough. A SQL injection pattern request getting a 403 before it ever reaches the application. So next one here is, yeah, API entry point, right? If you see here, um, so the load balancer, sorry, the TLS, the load balancer also owns the HTTPS boundary, right? The certificate comes from ACM attached to the HTTPS listener. So I could have terminated TLS inside the application container, but I deliberately did not. The certificate lifecycle and TLS termination are infrastructure responsibilities in this design, not the application ones. So the public API boundary is firewall protection plus ALB routing plus ACM managed TLS before traffic ever reaches my application. So then, of course, the VPC, public and private subnets. This runs in EU Central 1, so across two availability zones. Zone A and Zone B, if you can see here, the split into public and private subnets. The decision was not just AWS best practice. Okay, I was designing against a specific failure mode. My application and database do not need direct inbound internet access, so I did not give them one. Even if I misconfigure another control, the network topology itself is still a boundary. So ECS and RDS stay in private subnets. The public subnets only hold infrastructure that genuinely needs a public path, right? So next one is, yeah, Bastion. So next one is like Bastion host. which is controlled administrative access. So one EC2 Bastion host fixed elastic IP SSH only. I did not want anyone connecting directly from the internet to the private database or workload. Instead, there is one known restrictable entry point. There is only one bastion, so this is not highly available admin architecture. I accepted that because duplicating it would add cost without teaching me anything. I'm trying to learn from this deployment. In a stricter production environment, I would also evaluate system manager, session manager instead of a traditional bastion at all. So next one is NAT gateway, which is private outbound connectivity. If you see here, a completely different problem from the Bastion. The Bastion handles controlled inbound admin access. The NAT gateway lets private workload initiate outbound connections while staying unreachable from the internet. So I run one NAT gateway, a conscious cost versus availability trade-off. A stronger HA design would put one in each AZ to avoid a single NAT path. Repeat, a stronger high availability design would put one in each availability zones to avoid a single NAT path. I have not done that here because the environment does not justify the cost. Known limitation, not something I'm hiding. So next one is all about computing. So I consider EC2, Lambda, and a Fargate. So EC2 gives me the most control, but makes me responsible for patching and capacity management. So too much overhead for one containerized API, right? The same Lambda meant no server management at all, but this is a long-running API with a Postgres connection pool. So I didn't want the architecture built around ephemeral execution and connection lifecycle headaches. So Fargate is the middle ground. So a long-running containers, no host management. The trade-off is cost here. So well-managed EC2 could be cheaper at sustained utilization. I accepted the higher cost for lower operational overhead. So the diagram deliberately shows what's actually deployed. Like, if you see here, there is desired one and running one, right? Not an active fleet today. The platform gives me a path to scale later, but I'm not drawing capacity that does not exist. Next, moving on to the database, which is Amazon, RDS PostgreSQL. So the question is why PostgreSQL, right? The core domain is transactional. The tenants, users, inventory, purchase orders, invoice records, stock updates. Those relationships fit PostgreSQL naturally. The database stays inside the private network. Only the application tier has the path to it. One RDS instance today, not multi-AZ intentional. So multi-AZ improves failover, but roughly doubles the cost. For a production system with a stricter SLA, that would be one of the first change I would make. So next, the important operational things like authentication. So I didn't want application code responsible for password storage, login flows, and token lifecycle. Right? Those are solved problems. The Cognito gives me the managed authentication boundary, but this is multi-tenant, so authentication is not the whole story. The authenticated identity carries user and tenant context into the API, which is what enforces tenant scoped data access. So the flow here is Cognito, authenticated user or tenant context to ECS to tenant scoped RDS access. So I also built a separate super admin level for controlled access tenant administration and verified the tenant boundary using independently seeded organizations rather than just assuming a tenant ID filter worked, right? So next one is secret. So I didn't want database credentials living in source code, GitHub, Docker images, or checked in environmental files, right? So I use secret manager here. Secret manager separates the secrets from the artifact. IAM decides whether the workload can retrieve it. Clean responsibility split, right? So secret manager stores it, IAM controls access, the application consumes it at runtime. So the next one is like if you see here the IAM roles, execution role and task role. This is one of the mistake I made while developing. So ECS used two roles with a different jobs. The execution role is used by ECS itself, which is pulling the image, writing logs, and starting the task. The task role is used by my code at runtime. What gives the API permission to touch S3, Textract, secret managers, right? So I initially misunderstood the split, so deployed the Textract integration and got access denied. And assumed the execution roles permission were enough, but they were not. And the application inside the task has its own identity. So once I attached the right permission to the task role, it started working. So I'm showing IAM explicitly because it is not just configuration. It defines which component is allowed to do what, right? So next one is like more of an invoice pipeline. If you see here, so Amazon S3 will be the storage service which I'll use. So an uploaded invoice is stored in S3. So I wanted the original document to exist as a durable object independent of the application container. So I didn't want the API container become temporarily document storage, right? So S3 is the system of record for the PDF before any AI processing starts. So the flow would be S3 to Textract to the PO match service, which I'll come back later. So one question here is like I'm using Textract. If you see here for extracting all the information uh, from the invoice. So one question may come like, why Textract instead of custom PDF parsing? The alternative is normal PDF extraction plus regex and template specific rules. That works great when every supplier uses the same exact format and breaks the moment PO number moves, vendor changes the template or line items get laid out differently. So that is the reason I choose to extract, because I wanted the extraction layer to understand document structure rather than depend on positional rules. So the trade-off here is less control than a parser I wrote myself in exchange of handling real-world document variation. So the next one is PO match service, which is like it's more of a business logic stays outside the AI service, right? So extract job ends at extraction. So I don't want it deciding whether inventory changes. Um, extracted values go into my own PO match service, which looks up the PO and compares line items. I deliberately separated AI assisted extraction from business decision logic, so I can change how documents are extracted without touching inventory rules and change the matching policy without touching extract. So next one is why fuzzy matching, right? Yeah, supplier description rarely match internal names exactly. Like for example, the laptop Pro 15-inch versus 15-inch Pro laptop, right? So exact string comparison would treat those as different. So I use fuzzy matching that introduce a threshold decision. Too strict and valid invoices get flagged unnecessarily. Too permissive, the wrong matches get accepted. There is no universally correct number. So I tuned it by running real invoice variations and watching where false matches and false rejections actually occurred. So then the confidence, if you see here, matching confidence. So this is the decision I care most about. So above the confidence threshold, the match is trusted enough to proceed automatically, which is stock updates. Below it, the system stops. I don't guess. It doesn't guess, right? It routes to human review. And only after a person approves or flags it does anything change. I could have built extract match update fully automatic and I would look more impressive in a demo, but I deliberately did not. So, in my experience, when I am talking to the enterprise level of people, the leadership team and all, the one thing they are very worrying about, or scared about is, fully completing everything into automatic. That is the reason, like the human intervention is very, very important at the stage where it required. So the cost of wrong inventory update is higher than the cost of asking a human to look at the ambiguous case. So uncertainty is an explicit workflow state here. So that matters to me more than making the system look fully autonomous. So when you have HITL, like human intervention in it will is there, like the people will get a chance to review, which is like false positive or something like that, right? If it is not 100% perfect, if there is a lesson, if there is a less confidence score, then the human intervention will make sense to review it and approve it manually, so that we trust humans in that place without running everything automatically and then run into problem later time, which cost more to fix it. So one thing I wanted to mention here, if you see here the Amazon Bedrock blocked. So I wanted to create as an orchestration agent where I wanted to create one. I wanted to keep one model in place where the model can take it and run it automatically. But due to some subscription change and marketplace payment issue, I'm not able to get that Bedrock work now. But I'll keep working on it. I'll try to bring it. And yeah, I will try to get that. So next one is like CI/CD pipeline. So both pipeline starts with GitHub Actions. So backend, which builds Docker image, ECR, ECS deploy. I use ECR as the registry because I want a reproducible artifact. The same image that was built and tested in the is the image that gets deployed. No code built live on a running server. So the front end is, as I just mentioned, build S3 CloudFront in an invalidation and genuinely separate pipeline. This is one of the gaps I found while operating the project, not something I planned from day one. The backend was automated first. I was still manually building and syncing the front end. Once I noticed the inconsistency, I built the second pipeline and scoped GitHub action permission to exactly what it needed. So S3 and CloudFront, nothing more. So architecture does not become operational just because the diagram is complete. You find the gaps by actually running the system, right? So next come to the important portions, right? Observability. So I didn't want the architecture to end at the AP return 200. I also wanted to answer what happens when it stops returning 200. So the CloudWatch watches ECS, ALP, RDS, WAF, and application logs with the alarms on the conditions I actually care about. So one real example is during a deployment, ECS task count briefly went to 2 while the replacement task passed a health check. So then back to one once the old one drained. Because I had the metrics, I could tell that was normal rolling deployment, not an incident. So next one is SNS from monitoring to notification. So monitoring only matters if someone learns about the problem. So CloudWatch detects it as a condition, an alarm changes state. SNS send the notification, which I will show you in the AWS or in the upcoming demo. Like you can see the real emails which I received. So the loop here is like system behavior, CloudWatch, alarm, SNS, notification. The system does not just execute, it tells me when something is not behaving as expected. I hope it is clear because that's the complete architecture. I'm deliberately not presenting it as a highly available enterprise environment. It is not. So today, one Bastion, one NAT gateway, one ECS task, one Postgres instant, and the Bedrock integration that is coded but blocked. Every one of these is a deliberate trade-off or a known current limitation, not something I'm hiding. So what I wanted from this project was not the maximum number of AWS services. I wanted to work through the decision that show up once system design leaves the whiteboard. How should users enter the system? What belongs at the edge? What stays private? Which compute model actually fits at the workload? Where does identity live? How do application permission actually work? Where should AI be trusted and where should automation stop? How do deployments happen and how do I know when something got wrong? So this is what the architecture I wanted to show you, and I built NexusRetail on top of this architecture. So now let's switch from the diagram to AWS and follow exactly the same journey through the real environment. Okay, so before I open the AWS console, so none of what you are about to see was clicked together, right? It is all defined here. So when I added monitoring, that was the new file. When I fixed a security rule false positive last night, there was the Terraform change, not a console click. So I'm using Terraform here for everything. So I'll start with Terraform and then we'll move to, what is it? The AWS consoles. So I'll just quickly run through here. Yeah, so we can see the files which is already available. You can see here is ALB, compute, TCS, GitHub Actions, everything is going through Terraform. So none of it, goes through, from the console. So I developed everything here. So if you see here, everything is being sitting here. So from here, all the deployments are happening. So all the changes I'll be making it here and then deploying it through Terraform. So let me ensure like nothing is pending. Okay, let it run. So there are no, it should not be any changes. So it should be infrastructure should match configuration because yeah. So there are no changes. The infrastructure matches the configuration. So whatever I wanted to configure, everything is configured. Now we are good, really good to move to AWS console. So let me quickly switch the screens. One second. Okay. Okay, perfect. So what you see here is like AWS console. So one thing I wanted to mention here, like if you see in the architecture, I used Hero. as a region. So that should be properly selected. So I wanted to start, I wanted to show the console very quickly. I'm not going to go very deep. I just wanted to show you the same way what we have seen in the architecture. We'll start from route 53. So if you see here, route 53, this is my entry point. So the DNS, I host all the DNS in Route 53, and this is my host. This is my domain. And if you see here, there are three types of, there are three types, three zones which I've been using. So three A records you can see here. So this bad domain resolves to the ALB, that is, API. So the app dot goes to one CloudFront distribution. So www, if you see here, this goes to a different one. So different distribution ID, different origin. So as I said, the two separate resources, not the same thing twice, right? So this is what Route 53 does, and then we'll move to CloudFront. So you can see here, right, as I just mentioned, there are two independent distribution is happening. So two independent S3 buckets, both will public access fully blocked because only CloudFront can read from that either. So if you see here, yeah, one is for the www and another one should be for this thing. Second. Yeah, this is for the app. So the internet, cannot directly go to these kind of these things, and the public access fully blocked, as I just mentioned. The CloudFront can read, both the things are both, are either of this distribution. So next one is the firewall and ALB. So you quickly go to WF Shield. So you can see this is, and you can see the rules are being, so there are four rules which has been defined. I already mentioned. There is a common rule set, and there is a bad input rule set, and there is a SQL injection rule set, and also if you see the rate limit per IP. So here is the same event, WAF own all the logs and confirming exactly every rule, what is the rule is being catch and everything, right? Then we quickly move on to ACM. So I'm not going through, intentionally, I'm not going through each one of them very detailed way. I just wanted to show how the configuration and it should, align with whatever we discussed as part of uh, this one, the architecture. So TLS lives here, as you all know. So not in my application code, it lives here. And the CloudFront search specifically have to sit in US East one, regardless of where the rest of this runs. So that is what you can see. I can mention it here, right? Yeah. And we'll move on to the cluster ECS. Yeah. So cluster is, as I said, one Fargate service. So one running task, there are private subnets exactly as drawn. So if you see here, there is one task is running. So one service is active, right? So this is what it is. And then uh, one second, let me go with it. You can see all the logs here about the container, right? What is the CPU utilization and everything you can see here. So if you go to task, you can see here, right? Execution role. And if you see here, there is a task definition and task services. Yeah, you can see the task ID, last running, and everything you can see here, right? Then we'll move on to secret manager. You can see here, right? All the secrets are being stored here. So I don't want to go inside. So read at runtime by the task role. So never in the image, right? And never in a Git. So it is being stored here. So and then we'll move on to RDS, which is more of a database service. So as I just mentioned in our architecture walkthrough, I used PostgreSQL here because of all the transactional related stuff, right? You can see all the configurations here. So what is the class I have, what is the role and engine is Postgres and everything, right? and Cognito for my authentication side. So all the identities originated from here. So not on every request. The API validates the token it produced. So you can see here token signing by URL and everything will be used through uh, Cognito. So these are all the conscious decisions, right? As I explained in uh, through when we had the architecture walkthrough. So now the S3 bucket. So I just wanted to spend few minutes here. So S3 bucket, if you see here, one thing is the front end, which we discussed, right? As I said, the front end has a two different ways to come in. Right? One is app, another one is www. And I have the front end, also landing page, all the files, HTML files and everything being stored here. So that is a different things like API versus front end, what we have seen in our architecture demo. So there is a landing page, and you can see here the landing page, HTML and everything being stored here in buckets, right? So now the deployments will go to ECR, the registry. So all the deployments are happening here. You can see here, right? And backend, it is build, push to ECR, ECS deploys. That call never touches the load balancer. As you just see front end as a separate pipeline. So build sync to S3 and invalidate CloudFront. So I'll show you exactly why I have to and the gap that led to the second one when we are in the app, when I show the app walkthrough. So next important one I wanted to show is like CloudWatch here. So if you see the CloudWatch log management, you can see what is happening in the real time, right? See these kind of logs, whatever I have done today, I just, we can open and see, for example, if I want to see what is happening to the invoice, I just uploaded. You can see the entire thing, like, file received, stored, Textract extraction, there is no match, no PO number extracted, so the automatic match attempted. And then, likewise, it goes to everything. So if you see here one thing, which we will see when we show it in the app, in the real time, I'll run through. But you can see here the PO number is not found, so not extracted. So stopping, there is no automatic match attempt, right? Because there is no PO number match. We'll see some, the invoices with the PO number, and you can see like it is actually, extracted and store it in the S3 file, S3 bucket itself. So the last one is SNS, the simple notification service. So again, there is a threshold which has been set. If the alarm reaches the threshold, we'll be getting an email. So if you see here, I gave my email ID and I gave that email, and I just opened exactly the same email, and you can see today. Okay, let me see if there is anything new comes in. Okay, if you see here, yeah, 24 today. Like if you see here, just an hour before I recording this video, so there is a email because there is an alarm has happened, right? So this is the notification service which you will receive it. So this is what I just wanted to run you through on the AWS configurations whichever we have done. So it is not only whiteboarded, it is not only the architecture, it is actually set it up and actually developed. So now the next thing is like I wanted to give an app walkthrough, and we will see real time, how it is interacting with AWS, and we'll see like actual behaviors and actual patterns. Okay, so let's move on to the app walkthrough. So you can see here NexusRetail. Yeah. So this is the landing page which I wanted to, just wanted to keep involved, just to mention about the modules what I have and what are all the fun services I used and so on. So I don't want to talk about this application or a product, then it become a product page. So I just wanted to show you, how it is happening in the real time, right? So this is the intention is to give the application platform where the users will update all the inventories, and they can just place orders here. The major thing where AWS come into picture is like purchase orders, right? Where you will upload a invoice and so on. So there are three things I wanted to show here. One, the invoice which has PO match, so it is a happy path. An invoice which does not have a PO match, and which needs a human intervention, right? What we just discussed. So I'll upload the one which has direct it has everything. One second. Uh, I had few. Okay. So I used the same invoice which I've been using for testing. So if you see here, there is the the invoice which I uploaded is has a automatic match. So if you go back to S3, I'll see if the uploaded file is getting loaded in the bucket, and we'll go through check and check the CloudWatch logs whether it is performed better or not. So if I go to uploads, just open it here. Yeah, you can see here, right? So you can see here there is a invoice which I just uploaded, test invoice with PO. So it's showing here. Then quickly move on to CloudWatch and see the logs, what is happening. So I go to log management, I'll just go to the API, and yeah, I'll just open the today's one, just refresh it to see whether the logs gets loaded. So for the betterment, I'll just filter with the invoice. Let's see. It's a loading. The newer events are getting loaded. Just give a minute so we can see exactly what is happening. Okay. Yeah, it's get loaded. I think it's been a while. So I'm just refreshing it. Yeah. So you can see here, right? This is the one which we where it is. Okay, this is the one which we just uploaded. Test invoice with PO. I hope everyone can see it. Look at the log. So the file has been received, stored in S3, which we just saw. That extraction complete. The vendor is TechVision. So if you see here, you can see here, right? The vendor is TechVision distributors. And then the PO number is PO1001. So you can see here the PO number, we just uploaded the invoice only, and matching is found. And then the match result is status and everything. And you can go here, and if you open this, it will be automatically matched, and you can just approve and update stop. So there is no review or something is required. So the moment you approve, it is closed, right? So that is the normal happy path which you have seen. So what it is happening is like once you uploaded the invoice, the Textract will read the PO number in the invoice, and it goes and check the POs which has already been stored in the database, and it verifies, and if everything matches, it is automatically closing it. So next one, the important thing is like if there is any mismatch or if there is no PO number is not available in the invoice, the Textract or the system should not automatically approve it, right? It should be there should be human intervention. So this is why HITL will come into picture and human will review it and approve it. Let me check if I have a mismatch PO. I have the test data mismatch PO as well. So I'll run through the same flow. You will see. So if you see here, I just uploaded an invoice. So the PO number this needs review. So it says it needs review. Click to see what did not match. Like if I click here, the this PO has mismatches. So we need to review carefully. It is flagged. So I'll go and see the same thing. I'll just refresh the CloudWatch and see what happens in the AWS and what is the flow has happened. Right? 1 second. Let's wait for the newer events to get loaded. Yeah, so it is in loaded. So if you see here, there is a file received stored in S3. Okay, the Textract is completed. The vendor is the PO number is not found. So there is no PO number extracted. Stopping, no automatic match attempted. So the match result is status is flagged, right? So for PO number, this one. So this is how it works. So let me upload one more invoice. I'll just go to purchase order. So I just upload one more invoice and see. See, so it is more of this PO is not total matching in any of the forms. So we are not able to found PO number. So the no PO number is found in this invoice. The invoice does not have a PO, and we will not be able to automatically match it to a purchase order. So there is a different flow. If there is no PO, then the human needs to go and check, and there is a new series of event happen. That is what I was trying to do through agent, which I will elevate and enhance the system, and I'll show it to you, right? Right. So just that's what I wanted to show you, the purchase orders list, match PO and flag PO side by side. So the same pipeline, same extraction step, two different outcomes, because the outcome is not determined by whether Textract succeeded or not. It's determined by whether I trust the result enough to act on it without a person in the loop. That line is the actual design decision in this whole feature. I can review this and I can check everything. And then if I'm okay with everything, then I can approve and update. So that's NexusRetail end to end, not as a feature list, but as the decision underneath it. A network boundary I chose deliberately. Compute I picked after ruling out two real alternatives. An automation boundary I drew on purpose because I decided a wrong guess costs more than asking a person. Security I verified live, not just configured and hoped. A CI/CD gap I found in my own project and closed. A couple of real incidents I diagnosed with actual data instead of assumptions. I let you see exactly how those went, not just the fixed version. And one thing that's still genuinely open, right? Bedrock blocked on a payment issue that I have traced as far as I currently can, sitting there unresolved because pretending otherwise, would undercut everything else I just showed you. So going back to where I started, a whiteboard makes all of this look clean. Draw the box, draw the arrow, move on. None of what I just walked through was clean the first time. That gap between the whiteboard version and the real one is what I actually wanted to understand by building this. Codes on GitHub, an app is live, and I'm glad to go deeper into any piece of it, if you are interested to know more. Thank you so much for your time.